Assalamualaikum warahmatullahi wabarakatuh. Shalom. Hello everyone. Let me introduce myself. My name is Putri Saragi with student ID number 123490006, majoring in instrumentation and automation engineering. And in this video, I will be presenting assignment 5 for the Praktikum engineering drawing course. And the excitement is explain the basic function that have been learned in the practicum and design the NEMA 23 in English language in 10 or 15 minutes. Must be on cam. Dubbing is not allowed. First, we open the application of Autodesk Fusion. In here, we have create feature. In here we have new component. This feature creates a new component within your assembly or design document. The components are independent entities that contain their own sketch, body, and timeline. They are essential for organizing complex examples, enable motion studies, and maintaining parametric relationship between different parts of a design. Next, in here we have grid sketch. In grid sketch, enter the sketch environment where you can draw 2D profile using lines, arc, circle, point, and other geometric elements on a selected plane or face. Sketches serve as the foundation for most 3D features such as extrusions, revolvers, and sweeps. They can be fully constrained using dimension and geometric constraint to ensure precise modeling. And then we have grid form. Grid form is open the T-spline from environment, allowing you to sculpt organic and freeform shapes by pushing, pulling, and editing face, edge, and vertices. This is especially useful for industrial design, concept modeling, and ergonomic shapes. Each complete, the form can be converted into a solid body for future parametric operation. In here we have derive. Derive is import geometry, components, or parameter from another design file into the current document. The default link gives a reference to the original source, meaning updates in the source file can be reflected in the derived design. This is helpful for maintaining design consistency across real project. Next, automated modeling. Use algorithms to automatically generate design. Alternatives are filled in geometry based on defined constraints and objective. This tool leverage automation or generative design concept to explore possible design solution quickly without manual modeling. And then we have extrude. Convert a 2D sketch profile into a 3D body by extending it along direction. The extrude tool can add material like join, remove material like cut, or create new solid body. It's super tapered, symmetric, and distance-based extrusions, making it one of the most frequently used solid modeling feature. And then revolve. to the profile around an axis to create a solid or surface body. It's ideal for producing rotationally symmetric parts like shaft, wheels, and cones that revolve to allow you to define the rotation and angle and operation type like join, cut, or new body. Swap create a 3D body by moving a sketch problem along a path. This feature is useful for generating pipes, wires, rails, or any object that follows um, a curved road. Swap also support option for twisting, scaling, and controlling the profile alignment along the path. Next, loft generate a smooth transition between two or more purple on different planes or position is commonly used to create complex shapes that change cross-section gradually, such as aircraft, fuselages, or bottle shapes. You can add guardrails or center lines for precision shape control. Next rib. Rib adds this reinforcing wall or ribs between face or surface face to straighten the inward parts. The rib tool automatically calculates the rib thickness and placement commonly used in the injection molded plastic component or structural parts. Here we have web. Web is similar to rib, but creates flat or create like structure that support or connect part of a model. It's used to reduce material weight while maintaining structural integrity, often applied in lightweight, mechanical, or structural design. Emboss is project or rubs a sketch or text onto a chalk surface, either raised, embossed, or rigid or embossed. And this tool is ideal for engraving logos, serial numbers, or design decoration on complex surfaces. Next, hole is create standard holes like simple, contour bar, or contours with specific geometry wraps and third setting. The hole feature automated the creation of properly dimensioned holes and support hole patterns for mechanical fasteners. And then thread is at standard or custom threads to cylindrical face or holes. Threads can be mounted visual or as actual 3D geometry supporting both metric and an imperial standard. It's useful for creating 3D threads, bolts, or screw holes. Next box. Box is generates a rectangular 3D solid by specifying length, width, and height. And then boxes are often used best geometry or for quick conceptual modeling before refining the design with additional features. Cylinder create a cylinder solid by specifying a base cylinder radius and height. This primitive is commonly used as a base for rotational parts like pins, rods, and axles. Next part products spherical solid defined by its center point and radius useful for creating spherical joints, bearings, and or reference geometries. Next torus is forms a donut shaped solid with a measure radius like distance from center to top center and minor radius top thickness. This shape is often used for gated seals or ornamental design. Next coil is creates helical shapes such as springs or custom threads by defining pitch, revolution, and diameter Coil modeling is essential for mechanical components requiring elastic or rotational properties. Next, pipe is generates a hollow top along a selected path. You can define the inner and outer diameters, making it ideal for modeling fault conduct. Ring pads are structural tops. And then next pattern is duplicate. Feature bodies are fast in specific arrangements such as rectangular, circle, or along a path. The pattern tool saves time when creating repetitive elements like bolt holes or structural ribs. Next, mirror. Mirror is reflex selected features or bodies across a just plane, creating symmetrical geometry. This is an efficient way to maintain design symmetry without manually restricting features. Next, Deacon is converts a surface into a solid by adding thickness on one or both sides. This feature is useful then turning surface models into solid bodies for manufacturing or analysis. And here we have boundary fill. Boundary fill is this new solid body from enclosed regions defined by multiple intersecting solids or surfaces. It's a powerful way to combine, cut, or isolate specific volumes based on boundaries. In here, create this feature is adds non-parametric geometry when history, time, and evolution is used for direct modeling or when you need to establish foundational geometry before resuming parametric modeling. And last, we have create PCB is import or generate a printed circuit board or PCB design into Fusion 30 into Fusion 360, enabling integration between mechanical and electronic design. It helps align mechanical housing with real electronic components. Okay. In Autodesk Fusion 360, not just the create section but also modify, assemble, construct, inspect, and select. As in, I will explain its group and its measuring tools clear with detailed geometry. These are used after you've created a solid or surface. Common tools include press pull, allows you to extrude or offset fast dynamical by clicking and dragging them. It's like a combination of extrude and offset face. Next, fillet around the edge of a solid body by adding material to enter edge and removing material from extrude edge. Next, Gambar bevels the edge of a solid surface body by removing material from exterior edge or adding material to enter edge. And another feature in here we have cell, draft, scale, combine, offset face, repulse face, split body, short spill, move copy, line, and blank. Next, in assemble section manage component and their relationships in an assembly model. It defines how different parts interact or move relative to each other. Key tools include in here we have insert component, new component, duplicate with joints, constraint component, join. Join is a position component relative to its other in an assembly, then defines the relative motion between them. Join in Here, this is a connect to component with specific motion, contrast right, ridge, revolute, slider edge, defining how part moves. And then we have a split joint, rigid group, tangan relationship, joint origin, drive joints, motion link, motion study, enable contact sense, label all contact, build all materials, insert element vector part, and last insert track part. Supplier components have in here we have configure. Next in here we have to construct tool are used to create reference geometry like plans, x, and points. This reference guide, sketch, or aberration commands tool include offset plan, and angle, tangan plan, mid plan, plan drop to edge, plan drop 3 point, plan tangan to fast at point, plan along path, exit drop and then blank. We have to match feature. Next, in insert, inspect. The inspect tab provides tool for measuring, analyzing, and driving geometry. It ensures the design meets dimensional and manufacturing requirements. Important tools include measure, interference, curvature curve analysis, Gambar analysis, drop analysis, curvature map analysis, resource analysis, stability analysis, minimum radius analysis, section analysis, center of mass, displays, component colors, displays maps, space group, and next we'll insert. Section is used for bringing external elements into the design. You can import models, decals, or design data from other source data. Include is insert fastener, insert drive, decal, canvas, insert SVG, insert DX, if insert MC master core component, insert mass, insert element vector part, insert just part supplier components. And last we have select the select tab control how you interact with geometry in your design. It include option like select, window selection, from selection, pen selection, selection tools, component track, selection priority, and selection filters. Now we have to go to create one components. The component is NEMA 23. First we have the dimension of NEMA 23. We open the image. In here we can look the dimension of NEMA 23. Sorry, you can see in here. In here I have a NEMA 23, and NEMA 23 stepper motor is a medium size motor commonly used in applications that require high torque and precision control, such as CNC machine, laser cutter, and edge 3D printer. The NEMA 23 reverses the standard 2.3 cross 2.3 inches, like 50 7.2 cross 57.2 millimeter faceplate size, ensuring compatibility. Commonly 6.35 millimeter in diameter. When designing a NEMA 23 stepper motor model in a Fusion 36, I can start by creating a new component and then use precise dimension from a datasheet. The design process usually begins with a sketch of the front faceplate, a square with rounded corner, and for mounting a host position. Um, in this symmetrical, and then using the extra tool, you can I give thickness to the body and add details such as the shaft, which is typical of cylinder extending. The designing a Lima 23 motor in a version 360 is not just about a visual representation, it is also usable for mechanical integration by modeling it accurately. I can check like mounting fit and soft coupling with other component in high assembly, ensuring that the motor fits perfectly within my mechanical design, whether application or 3D printing.